Okay, let's dive right into this explainer. Today we are focusing on mastering Igcse Physics electrical safety questions. Now, this is a seriously high-stakes topic that appears in almost every single examination series. Whether you were sitting the Cambridge 0625 paper or related syllabuses like 0651, 0652, 5054, or even if you're looking ahead to the 9702 advanced levels, you absolutely cannot afford to drop marks here. To really set the scene for you, I want you to picture a real Cambridge physics past paper question sitting on the desk in front of you. The clock is ticking, the invigilator is walking up and down the aisles, you turn the page, and there it is. A massive 8-mark, multi-stage beast of a question focused entirely on electrical safety hazards. Now, I want to introduce you to two very typical students we see constantly highlighted in the principal examiner reports. First, we have Alex. Now, Alex works incredibly hard. Alex knows the textbook inside and out and overloads the page with raw physics facts. We're talking about a complete novel about electrons, charge flow, and atomic structure. But here's the problem. Alex provides absolutely zero structural analysis. It's just a brain dump of information. Then, on the other end of the spectrum, we have Sam. Sam looks at the clock, rushes the paper, and panics the second a complex circuit diagram appears. Sam completely misses the specific command word requirements in the prompt and just scribbles down a one-sentence, incredibly generic answer, hoping for the best. Well, both of these approaches are fundamentally flawed, and right now, both of their exam papers are practically bleeding red ink from the examiner's pen. Alex misses the point, and Sam misses the detail. Today, in this session, we are going to completely overhaul these approaches. We're going to transform those red crosses into solid, undeniable green check marks. To get us to those top grades, here's our flight path for today. First, we'll tackle the electrical safety challenge head-on. Second, we'll break down the core physics principles you actually need to know. Third, we're diving into the method mark strategy. Fourth, we'll expose the top examiner warnings. And finally, we will build out your ultimate exam success framework. All right, starting off with Section 1, the Electrical Safety Challenge. We really need to understand the academic benchmarks that separate average, middle-of-the-road grades from those absolute top-tier scores. So, the fundamental question we have to answer right out of the gate is this. Why does multi-stage analysis on electrical safety cause so many dropped marks across the board, year after year? Think back to our two students, Alex and Sam. Alex clearly knows the foundational physics. The facts are all there in Alex's head, but Alex completely lacks the technical methodology to apply those facts to the highly specific scenario provided in the exam prompt. Sam, meanwhile, just lacks the strategic patience to decode the command words that tell you exactly what the examiner wants to see. The real challenge, the trap that so many students fall into, is that electrical safety questions are almost rarely just a simple one-step recall exercise. They demand more from you. They require you to extract specific data from a block of text or a complex table. Then you have to interpret the physical relationship at play. For example, you need to understand exactly how electrical resistance changes in damp conditions. And finally, you have to synthesize that into a highly specific evidence-based conclusion. If you just write down something vague like electricity is dangerous and water is bad, well, you're completely failing to meet the rigorous analytical depth required by the Cambridge Assessment Framework. You're leaving points on the table. Let's transition into Section 2, Core Physics Principles. We need to see exactly how this analytical depth builds directly from the absolute core laws of physics. Listen, you absolutely cannot analyze a complex system if you do not fundamentally understand its individual components. These right here are the specific, universally tested hazards that form the absolute bedrock of your exam questions. We need to lock these into your memory. First up, damaged insulation. When the plastic coating breaks down, exposing the live copper wire, it creates a severe, immediate shock hazard. Why? Because the human body acts as a conductive path directly to the earth. Second, overheating cables. This is all about energy transfer. When cables are forced to carry too much current, the electrical energy is rapidly transferred to thermal energy. If that thermal energy can't dissipate, it melts the insulation and you've got a massive fire hazard on your hands. Third, damp conditions. This is a classic trap. Water, especially impure tap water or sweat, drastically lowers the electrical resistance of human skin. Going back to Ohm's law where voltage equals current times resistance, or V equals IR, if resistance plummets, even a moderate household voltage can drive a highly lethal current right through the body. Fourth is excess current from overloading sockets, plugging too many high-powered appliances into a single extension lead. And finally, you have to know the structural setup of the main circuit inside and out, the roles of the live, neutral, and earth wires. Plus, you need to memorize the absolute critical golden rule of circuit safety. A switch must always be connected to the live wire, not the neutral wire, the live wire. This ensures that the appliance is completely isolated from the high-voltage source the moment it's turned off. Now, what's really fascinating about how these exams are marked is a very clear examiner preference. The assessment framework heavily prioritizes analytical depth over superficial breadth. This is exactly where we introduce the ultimate, absolute game-changing strategy for structuring your physics answers, the PEEL framework. That stands for Point, Evidence, Explanation, Link. Think about it. Superficial breadth is what Alex does. It's writing down 10 random, loosely connected facts about circuits and hoping the examiner finds one they like. Analytical depth, on the other hand, is deliberately using PEEL. You state a specific point about the hazard, you pull concrete evidence directly from the question's diagram or data table, you offer a rigorous physics explanation using the correct terminology, saying something like increased resistance leads to a higher rate of thermal energy dissipation, and finally you link it all back to the specific safety consequence demanded by the command word in the prompt. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, let's do a quick interactive challenge. If we put 30 seconds on the clock right now and asked you to spot which sample answer on a past paper actually used the PEEL framework, I guarantee you'd instantly see it. It's the one with crisp, clear, logical steps. It is not the messy, rambling paragraph of brain-dumped facts. It stands out like a beacon to the examiner. So here is a crucial, high-level takeaway. Integrating these safety hazards with other syllabus areas, rather than treating them as isolated little islands of information, is exactly what the top-scoring elite candidates do. The principal examiner reports explicitly highlight this year after year. If you are writing about overheating cables, don't just state it gets hot. That's too basic. Connect it directly to the power equation. Show them you know that power equals current squared times resistance. Explain the rate of energy transfer mathematically. If you are discussing how the earth wire functions, connect it to electromagnetic induction or explain the precise mechanical operation of a circuit breaker. Making these cross-topic connections proves definitively to the examiner that you understand physics as a beautifully interconnected, unified system, rather than just a stack of isolated flashcards you memorized the night before. Moving right along to Section 3, the method mark strategy. Knowing the theory is great, but it simply isn't enough. Let's unpack the actual technical methodology you need to physically capture those points on the page. Let's break down the standardized sequence you absolutely must follow for the systematic processing of exam data. Let's do a live rewrite of Sam's terrible, rushed answer right now in our heads. Step 1, identify key elements. Sam needs to slow down, grab a pen, and physically circle the command word. Is the question asking you to describe, explain, or calculate? Those mean very different things. Step 2, apply relevant principles. Mentally pull the correct formula or safety rule from your mental toolkit. Step 3, execute the analysis with clear step-by-step working. Step 4, verify your results. Take a breath and ask yourself, does this answer actually make physical sense in the real world? Step 5, present your final answer in the appropriate format, making absolutely sure you have the correct units and the right number of significant figures. Honestly, if you gave yourself a strict 60-second visual timer during the exam to just mentally outline these 5 steps before you write a single word, your potential for securing top marks goes from 0 to 100% almost instantaneously. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Now, I really want you to listen to this examiner alert carefully. Your clear, fully annotated working out is your ultimate, undeniable safety net during any physics exam. Let me be incredibly bluntly clear here. The examiners actually want to give you points. They are actively looking for reasons to award you marks, but they literally cannot give you method marks if your brilliant method is locked inside your head. Showing your working step by step is the professional standard in physics. Even if you mess up a final calculation on your calculator, a perfectly laid out method will catch you and secure the majority of the points. Let's push forward to Section 4, Top Examiner Warnings. To protect those precious method marks, we need to look directly at the principal examiner reports to see exactly what goes wrong for thousands of students globally. These top 3 mistakes are devastatingly common, but they are entirely, completely avoidable if you just practice proper formatting and contextual specifics. Let's play a quick mental game of find the flaw. Imagine a sample student paragraph on a test that says, "The wire is dangerous because it is old and will shock the person." Think about that for a second. Which of these top 3 mistakes does that exact sentence violate? Well, it violates number 1 and number 3. It's way too vague. Old is not a recognized physics term.
Damaged insulation is the correct terminology. Saying it will shock someone is incredibly weak. Saying it provides a low-resistance path for current to flow through the user to Earth is the exact, highly specific, contextual detail the examiner demands to see. You have to train yourself to ruthlessly hunt down these vague, everyday statements in your own writing and eliminate them entirely.
Here's another massive trap. If a question asks for a comparative analysis, you cannot, under any circumstances, just list the differences. You must identify both the similarities and the differences using sophisticated comparative connectives and specific evidence. Let's do a quick mental data scan challenge. Imagine a complex physics chart comparing two different circuit safety mechanisms. Let's say a traditional fuse and a modern circuit breaker. You have 60 seconds to scan the core trend. Don't just look at it and write, fuses melt. You need to elevate your language. Say something like, both devices are similar in that they protect the circuit from excess current. However, whereas a fuse melts due to thermal energy and must be physically replaced, a circuit breaker relies on electromagnetism to trip a switch and can be easily reset. Do you hear the massive difference in quality there? That comparative connective, the word whereas, is a massive, glowing green flag to the examiner that you are executing high-level critical analysis, not just passively listing memorized facts.
All right, let's bring it all together in Section 5, the Exam Success Framework. We are going to synthesize everything we've talked about into a professional, repeatable framework that you can start applying immediately to your past papers.
Top-tier candidates consistently demonstrate evaluative thinking through a very specific three-stage problem-solving cycle: deconstructing the provided information, solving the problem systematically, and then evaluating their final answer with justified reasoning. This cycle forms the foundation of our 3 unbreakable rules for exam success. Rule number 1. Command word decoding. You must deconstruct exactly, precisely what the examiner is asking you to do. Rule number 2. Peel framework application. You solve the problem by making your point, providing hard evidence, explaining the underlying physics, and linking it back to the prompt. And rule number 3, the time management matrix. You have to constantly evaluate your progress. Don't fall into the trap of spending 10 solid minutes writing an essay on a simple 2-mark question about a damp switch, only to realize you now have to rush a massive complex 6-mark calculation on circuit overloading on the very last page. I want you to memorize this exact 5-step sequence for tackling every single question. This ensures you use the proper terminology and clear notation every single time you put pen to paper. Let's do a high-pressure speedwriting challenge right now. Imagine a 30-second timer ticking down on the screen. If I asked you to write one perfect peel paragraph explaining exactly why a switch must be placed in the live wire, you should instantly spring into action. Deconstruct the prompt. Extract your data. You're dealing with a switch, a live wire, and an appliance. Select your framework, the principles of safety and isolation. Execute your point. The switch must be connected directly to the live wire. Present your explanation, because when the switch is open, it completely breaks the connection to the high-voltage mains supply. This thoroughly isolates the appliance so that if a user accidentally touches the internal metal casing, absolutely no current can flow through them to the earth, thereby preventing a fatal electric shock. Boom, that right there is how you guarantee full marks. No fluff, just pure structured physics. To help you lock all this in, I want to give you a highly effective memory hack pulled directly from advanced study methodologies. You need to build an acronym for these specific hazards so you never ever freeze up under the pressure of the exam hall. Let's create one together right now. Think DODEMS. DODEMS. Damaged insulation, overheating cables, damped conditions, excess current, main circuit, switch in the live wire. DODEMS. When you finally sit down in that quiet exam hall and you turn the page to a massive 8-mark question on electrical safety, the very first thing you do is write DODEMS lightly in pencil on the margin of your paper. By doing that, you have instantly downloaded the entire syllabus requirement for this topic, right from your long-term memory into your active working memory. It acts as an incredible mental checklist, ensuring you absolutely do not miss a single critical factor when the question asks you to fully evaluate the safety of a given diagram. It is a total lifesaver. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.